Let's solve LEETCODE question 51 n queens. It's a hard LEETCODE question. N queens puzzle is the problem of placing n queens on a n plus n chessboard such that no two queens attack each other. Giving an integer n, so like it gives you an n, that's basically meaning the board will be n multiplies n, basically 4 by 4, right? Return all distinct solutions to the n queens puzzle. You may return the answer in any order. Each solution contains a distinct board configuration of the n queens placement where Q and dot both indicate a queen and an empty space respectively. So this apparently is the queen and this is like the empty space. And then it basically gives you, for example, like this, it gives you n as 4 and the queen is not able to attack each other, and you can have these two placement. I feel this question is not such written is because it didn't really tell you how the rule, like for somebody like me, I have no clue how to play these chessboard games. Like I don't know how they can attach each other. So the rule is that if two queens cannot attack each other, is that they can be in the same row and they cannot be on the same column, and they cannot be on the same diagonal, like this direction or this direction. If you pay attention to the answer here, you look at the rows are easily visible, right? Each queen is in different row and each queen is also in different column. But the diagonal is that if you look at this diagonal here, the queen is there's only one queen here in this diagonal and only one queen in this diagonal, and it's same thing if you look at the diagonal in a different direction, there's only one queen here. So basically this is the rule. That's why it returned this two possibility as the answer. If n equals to 1, there's only one grid here, so you basically place the queen in here because n equals 1, right? There are some constraints here, and it's an interview question asked by a bunch of company in the past 6 months. This is a hard question, and it's a good question to practice on as long as you know how to handle the situation, like I think the rows and the columns are really easy to handle in code, but we have to think about it, how to handle this for the diagonal situation. How do we make sure that when we place the queen, that we don't place them in the same diagonal? So if you do some calculation on the rows and the columns, say this is column 0, 1, 2, 3, right? And this is row 0, 1, 2, 3. If you calculate this diagonal, there are two types of diagonal here. And then this one diagonal is the high goes lower. I'll call it a high-low diagonal. The high-low diagonal, if you look at it, is if the row count minus column count in each diagonal, they actually equals the same thing. This is how you should be handling it in code. Once you know how to handle this, you will know how to write this in code. Basically, for example, like this row and column, if they minus, the middle diagonal here is all 0. If you look at it here, because column and row equals together, that's why this is 0 here. And then when you go up further, you will see diagonal 1 calculated to 1, and so on and so forth. And if you calculate the diagonal on this side, basically it goes from low to higher, then you basically will find one thing in common is that this is row 0, column 0. It adds up to 0, right? And then if you look at this one is row 1 and column 0, it when row plus column, that's 1. And in this one, the diagonal is also the sum of the row and column is also 1. And if you continue to go further, this guy is 2, and then this guy is also 2, and this also is 2. So the high-low diagonal direction, you can set it as row minus column, and the low-high, you can calculate the number as row plus column, and they all equal together. And in this, and you can basically use our set to record all the calculation for R minus column and R plus column. And besides that, you also want to use one more set, because when we start with the row, right, we know that we iterate through each row, so we don't have to worry about placing one queen in one row, because the rows are going bigger and bigger, right? So for the column, we want to use a set to go through the column. So total, we need 3 sets to store all the information. And then one is the column set, and then 2 set for the diagonal calculation. And then we can use the backtracking to, this is such a typical backtracking question because it asks you to give all the combination that is possible, right? So the base condition is that once we iterate through the entire row, when the row equals 4, then we found the answer, and then we can just append the result and then return it. And then for the rest, that we just roll out the edge cases, and then we change every time we find a cell, then we just change the board to the queen. And then we're gonna call the backtracking function. So I'm gonna show you how to do this in code. So I'm gonna use a column set, so 3 set, and for the diagonal goes this direction, I'm gonna call it as high-low diagonal, and you can call anything that you like. And I'm gonna use a set to store this, and then the low-high go from this way to the higher, and low-high diagonal, I'm gonna use another set, and then so there will be a result like this, right? So first I'm gonna initialize the board to everything as a dot. So basically it will be something in Python. This is how you do it, and you want to plug n for I in range n. Yep, that's how you do it for the board. So all the board will look like, every single cell will look like dot 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 right now, and then basically indicate it's the empty cell. And then you want to write a backtracking function. So I don't like to backtrack too many parameters, so I'm only gonna backtrack the row count. And then if row equals to n, so that means we already go through the last row, we already find the combination. So at that time, we want to append the output. The output will actually be we want to join the row together, and this is how you do it in Python for row and board. And then you want to append in the end, you find the result, and then you want to join the row together and append it to the board, and after that you return it. That's the base condition when you find the answer. So for C, and then we want to iterate through the columns for C in range of n, right? Because I also have 4 columns here. And if C encodes, if the column is in the set already or R minus C, remember in the high-low diagonal, we mentioned that it's row minus column. Row minus column are equal, right? So all R plus C in low-high diagonal here. If that is the case, I want to continue. Not going to do anything about it. Otherwise, I'm going to add, if they're not in the sets already, what I'm going to do is I'm going to add the column to the set, basically indicating that I already visit that. And the high-low diagonal, I want to add R minus C. Low-high diag, I want to add R plus C, right? And then that means that I'm going through this row and the column, and I found a place to play the queen, and I'm going to change the board, the RC equals to queen, right? And then if I find this, how do I find the next one? And then just based on the parameter, and I'm going to call the backtracking function, but it will be R plus 1. That's how you do backtracking. And then backtrack it, we need to revert all the changes to backtrack it. How we do backtrack it is basically, you see here, right? We want to revert everything that we have done in the previous step. How we do it is we want to remove it in the C so that they can be, the same number can be added again. And we want to remove this as well. And since we have set this to queen before, right, backtrack it. And then we want to revert it back to the empty cell. And that's it. That's all for the backtracking function. And then I'm going to call the backtrack function. And row, I'm going to start from row 0, right? And I'm going to return the result in the end. I think that should be right. Oh, if, yeah, it's a typo. If C in call, RC in minus, okay. Yep, it's correct. Please give me a thumbs up and subscribe to my channel if you think this is helpful, and I'll see you soon with more LeetCode question. All right, bye-bye.